Hi, Les Driven with part 1 on completing the duct design calculations for residential application. Page 2 of the worksheet contains parts A, B, and C. What I recommend is that you look at the video on equipment selection, and in that video you will be shown how to complete the 3 sections on this page. However, to continue our discussion on duct design, I want you to take the cooling airflow proportioning factor and the heating airflow proportioning factor and place them on page 3, part D, determining the room and air design airflow rates. Put the cooling multiplier here and the heating multiplier here in row D6. Then what you need to do is refer to the summary of your heat loss calculation. So here you've got all the BTU heat loss and gains for each room in the house, and you simply transfer these values onto page 3 of the duct design calculation sheet. Once you've got all your heat gains listed and your heat losses listed, the next step is to convert the BTU gain into a cooling airflow rate. That's where this factor comes into play. You simply take the BTU heat gain for each room and you multiply by the airflow factor. So for the basement you would take 566 BTUs times 0.0435 and you'll get 25 CFM. Moving on to the kitchen, you would take 2640 BTUs times 0.0435 and you would get 115 CFM. Simply carry that calculation through and you will get all of your cooling airflow rates. Then go back and do the same thing for getting your heating airflow rates. So for the basement you would take 6,170 BTUs, multiply that by 0.0265 and you would get 164 CFM. Simply carry that same calculation and you will get all of your heating airflow rates. Then you want to tally up the individual floor rates so that you can break the required airflow rates down for each floor level. And you also want to tally up all of the airflow rates to verify that the total amount that we've got are in fact close to the required amount. And if you have a quick look back at your part B, you'll notice that the heating airflow rate is 710 and the cooling airflow rate is also 710. And so in our calculation here we've got 709 CFM for cooling and 712 CFM for heating. The difference is simply created by the rounding up or the rounding down of these values as you go through the multiplying process. Now the next step here is to determine the number of outlets per room. My suggestion is that for the basement you would divide the larger airflow rate. In this case the heating airflow rate is the larger of the two. I would divide 164 CFM by 60 CFM per heat run. And this will give us 2.5 heat runs or so we would round that up to 3 heat runs. Now in all the upper floors, in the kitchen, family room, and so on, my suggestion is that you take the larger of the two airflow rates and you divide them by 80 CFM. 80 CFM is a very good number that you can easily get out of your typical 6-inch heat run. So if we take, in the kitchen, in the case of the kitchen, if we take 115 CFM divided by 80, we're going to get something in the range of 1.25 or 1.3 runs. So you simply round that up to 2 runs. Now for all of the other rooms, we can see that all of these values divided by 80 is going to be actually less than 1 or equal to 1. And so therefore each room only requires 1 run.